Hello and welcome to another video by Heybridge High School's Maths department. In this video I'm going to be focused on reading and writing function notation, substituting numbers and expressions into functions. So the first, I'm going to split it into the three sections. The first section I'm going to discuss is reading and writing function notation. So what is a function? By definition, a function is a relation between a set of inputs to produce a set of outputs. So let's start off with something that we've seen before. So we have the equation y equals 2x plus 1. You should recognise this as a straight line graph. So if I was to ask you this question, can you find me a coordinate on this straight line graph? Hopefully, you would all know to substitute in a value of x and produce a value of y. So if we let x equal 1, hopefully you would write y equals 2 times 1, and we're adding the 1. So we need to remember here, we've written it in brackets, but it actually just means that we're timesing them together. So if we times them together, we would be left with y equals 2 plus 1, and y would equal 3. So that in itself, we have put an input of x equals 1 and got an output of y equals 3. So that is a function. So if we see a function as a machine, we're starting off with one thing and coming out with another. So if we look at the same example, we're starting off with x. Substituting a value of 1, so we'll carry on with that. But first of all, x needs to go into the machine. It starts off being multiplied by 2. We will get an answer. That answer would go into another machine, we would add 1 to it, and we would be left with our y value. So if we go back and substitute in our value of 1, so we need to do 1 times 2, which would give us 2, and then we need to do 2 add 1, which would give us 3. So this is just an example of a function machine. This isn't the only way that we might see a function. So remember, this is a straight line. So the actual notation for a function is as follows. So what we have here is the notation for a function. All this means is f is a function. So I've just highlighted f for you. We then have x as its input, and then we will be given the output 2x plus 1. So we do the exact same process as previously, it's just noted differently. So this is just another example of the notation for function. So f of x is equal to 2x plus 1. So it's doing the exact same of the previous question. So f is our function in this case. X would be our input and 2x plus 1 is our output. However, it is key to note that f doesn't always need to be the function. So we can have the function to be a g or b to h. It's just in these examples I've used f. So let's move on to substituting numbers into our functions. So let's look at some examples. So if f of x is equal to 2x plus 1, same as our previous one, we need to evaluate for the following. So when f of x is equal to 0, this just means our input is going to be 0. So whenever we see an x, we need to substitute it for a 0. So it would be 2 times 0 plus 1. We've done 2 times 0, 0 plus 1, which just gets us 1. So the next one, evaluate f of 1. So input is going to be 1 this time. Whenever we see an x, we need to substitute in 1. So we've got 2 times 1 plus 1. So we've got 2 plus 1, which is equal to 3. So our last one, f function of f minus 1. So input this time is -1. Where we see an x, we need to substitute in -1. So we'd have 2 times -1 plus 1. So 2 times -1 is -2. Adding 1, we're left with -1. Next example. So function here, where function is g, input is x, and our output is x minus 10. So evaluate the following. So g is equal to 0. So our input this time is just 0. So whenever we see an x, we need to substitute for a 0. So it would be 0 minus 10. 0 minus 10 is just minus 10. Next one, our input is 1. So when we see an x, we need to input 1. So we would have 1 minus 10. 1 minus 10 minus 9. And our last one, so our input is -1. Whenever we see an x, we need to substitute in -1. So we would have -1 minus 10, and that would just get us -11. Next example, so we've got a quadratic this time. Same principle, we've got the function where y is our input and our output is y squared plus 2y. So f of 0, so whenever we see a y, we need to substitute it for a 0. So here we would have 0 squared plus 2 times 0. So we've got 0 squared, which is 0, plus 2 times 0, which is 0. Our answer is 0. Next one, whenever we see a y, we need to be substituting the value 1. So we would have 1 squared plus 2 times 1. So 1 squared is just 1, and 2 times 1 is 2, and we're left with 3. Fabulous. Last one, so when we see a y, we substitute it for -1. So we would have -1 squared plus 2 times -1. So -1 squared is just 1, plus 2 times -1 would actually be -2. So we're then left with 1. The minus cancels out with the positive, so it would be 1 minus 2, so we're left with -1. Another example, so our function is h this time, input is x, and our output is 5 minus x all squared. So evaluating when h is equal to 0, so whenever we see an x, we need to substitute in 0. So it would be 5 minus 0 all squared. So 5 minus 0 is just 5. And that's all squared, so 5 times 5 is 25. Next one, so whenever we see x, we need to substitute in 1. So we would have 5 minus 1. So careful here, so remember my function is 5 minus x. I've done 5 minus, and x is just 1 here. So I need to make sure we're watching our negatives, and that function is all squared. So we would have 5 minus 1, which is 4, which is squared, so that leaves us with 16. So next one, so whenever we see x, we need to substitute in -1, so we would have 5 minus -1. So I would always leave it in brackets whenever you're handling negatives, because we tend to make mistakes here. We might ignore the negative and just put a plus instead. Always work with brackets. So next here I've got 5 minus -1, so minus becomes a plus, so I've actually got 5 plus 1, which is 6, which is all squared. I've got 6 times 6, which is 36, all done. So next, let's move on to the next part of the video, which we will be substituting in expressions into our functions rather than numbers. So here's an example of substituting in an expression. So Only difference here is that we're dealing with algebra rather than numbers directly, so we do the exact same process. So our function here is f, our input is x, and our output is 3x plus 5. So evaluate when the function, our input is y. So this time, whenever we see an x, we need to just substitute in a y. So f of y would just be 3y plus 5. Done, finished. We can't do any more there because we've still got an unknown. We just leave it in those terms. They're in their simplest terms, so all finished. Next one. So when f, evaluate the function when t minus 2. So this time whenever we see an x, we need to substitute in t minus 2. So we would have 3 brackets t minus 2, because originally it's an x, but we're substituting in t minus 2, plus 5. So we can't leave it there because we can actually expand out our brackets. So if we expand the brackets out, we've got 3t minus 6 plus 5. Don't finish there because we can collect our terms of the minus 6 and plus 5. So we're left with 3t minus 1. Stop there because we can't collect any more terms and we can't simplify. Next example. So we've got the function when it's 2x. So we substitute 2x whenever we see an x, sorry. So we would start off, we've got 3 times by 2x. So we're just replacing that x with a 2x. And we add by 5. So we need to expand out our brackets. So if we multiply the 2x by 3, we're left with 6x plus 5. And we're all finished because we can't collect any more terms. So let's look at our last example. So we've got the function g of x is x squared plus 5x, and we're evaluating when g is minus y. So whenever we see x, we need to substitute it for the minus y. So that would mean that we have minus y all squared plus 5 times minus y. So remember with quadratics, if we've got minus y squared, it just means we have minus y times minus y, which would just be y squared. So remember, minus times a minus cancel out, we get positive. Y times y would just be y squared. So our next line, we'd have y squared, and then you have minus y times 5, so you'd have minus 5y. So if we want to leave this in the simplest form, we can actually take out a factor of y. Might not always ask you for this, depends on the question. Can't always do this step, but it's because I've got a y in both terms. So I'd be left with y minus 5. Okay, so next one, g is 2t. So whenever we see x, we need to substitute in 2t. So we have 2t squared plus 5 times 2t. So again, if we just go to the side and work out our squares, so we've got 2t times 2t. So let's deal with the numbers first. 2 times 2 is 4. If we've got t times t, it would be t squared. So our next line is 4t squared, and then we've got 5 times 2t, which is 10t. And again, we can take out a factor of t in both, and we've got a number that we can take out in both as well. So if we take out 2t, we will be left with 2t plus 5. So our last one. So a bit complicated here because we're dealing with x's and x's, but the process will still be the same. So whenever we see an x, we need to substitute in x squared. So we will have x squared all squared plus 5 times x squared. So if we go take over here and we'll do our squared, so we've got x squared times x squared. So what's our rule of indices? If we're timesing, it means we add them, so it would just be x to the 4. So if we go back, this is a skill that you, if you're not confident on, have to go back and watch the videos, but it'll all be explained there. So we've got x 4 plus we've got 5 times x squared, so we'd be left with 5x squared. And again, let's factorise out x squared as it's in both terms. So we've got x squared plus 5. So that's all for today's video. Thank you for watching.